In summary, freeze desalination can be used for saline water of any concentration. That means you can use the process for the nano water, for reverse osmosis retentate water, water from mining industries, petro products, process waters. Not only that, you can also use it for textile industries, water from that, and also from leather industry and the like. So for all the all the type of water, you can use it freeze desalination successfully. It can remove not only the TDS values, we can also reduce chemical oxidant demand, COD value also, which has been established, well established in experimental runs. So that means water scarcity or water security has been assured, and there is a scope that the water scarcity can be converted to water surplus state, and I visualize that there can be water exports, water trading is possible from a surplus state to deficit state. It may be a fairly good industry in future because of the versatility of water available, and there is no more overdrawing from the groundwater. And apart from that, the second point is the cost factor. Now, for the RO plant with a normal salinity water, the power consumption has been estimated around 3 to 5 kilowatt hour per cubic meter of water treated. For the freeze desalination plant, the power consumption may be around 5 kilowatt hour per cubic meter for the normal salt water. And in the case of RO plant, the power consumption will go multiple times with the increase in concentration. Whereas in the freeze dissolve process, the power consumption will go marginally higher. That is the second point I want to emphasize. What I mean is the power consumption will be much lower than the existing plants. It may be, but these things has to be established. And the third point is the pollution control. Pollution from RO plant is well known. They take out about 30% water, and the remaining 70% water is discharged to the sea or the nearby water streams. Whereas in the case of freeze dissolve system, you can recover up to 70% water by normal process, and it can go to nearly 90% also to some extent, and which means the recovery of water is much higher, and the pollution or the concentrated water that is discharged will have high salt contents, which can be recovered and reused for the system. These are the 3 points which I want to refer. Hope this applies to both existing plants as well as for the new upcoming plants. For establishing this concept, we do require pilot plant studies, and for this purpose, we require well-talented cryogenic engineers and experts in desalination industry to standardize the process conditions, mainly for the freezing temperature for different liquids, the time required, and the number of stages required. So all these things has to be established by cryogenic engineers and a team of engineers, for which we require equipment as well as expertise. Apart from that, we do require a good marketing team who will be highlighting the process conditions to the new coming industries as well as the existing industries to highlight the benefits. In summarizing, we have developed three major milestones. The number one is introducing of a new concept of repellents, which eliminates the pre-treatment, the washing of eyes, and gives lot of benefits to use water of any concentration. The second is boron removal, which was very important for many countries where borated water is a big problem for the agriculture and for the human consumption. And the third one is pollution. Pollution for which we have developed a cold zero liquid discharge process. Cold cryo ZLD we call. And by this process, we can remove all the salt from the system, remove the thing, and the treated water can be safely discharged to the nearby water streams, thereby reducing the pollution and also increasing the water recovering of input raw materials as well as the energy consumption. So with this, I conclude and thank you a lot. Bye.